Alright, so last time we learned that when an equation is written like this, it's a very famous form for the equation. It's called the slope-intercept form. So the reason it's called that is because you just look at it and you know one of the points already. The y-intercept would be 0, b. Right? That's what you should be thinking. As soon as you see that, you think, hey, the line has to go through the point 0, b, whatever this b may be. Well, whatever that b may be. And you just look at it, and you just by looking at it, you realize that this has to be the slope. So this tells you the steepness. Just by looking at it, and that's what's nice about this form. In two seconds, you can graph them every time it's written this way. You can just look at it, you know a point and a slope. Well, today we extend on that idea, and here's the extension. Suppose you have an equation that looks like this: y minus 2 is equal to 3 times x minus 1. Every single time you've got an equation like this that has, I'll give you the generic form. If it looks like this, y minus k is equal to m times x minus h, you should be thinking, whoa, it's duck soup, piece of cake. After today, you will think that this is super famous. It's almost as famous as this one, maybe even more famous. This one's called the slope-intercept form. This one is called the point-slope form. Slope form. Okay, and the reason it's called that is because it's for exactly the same reason as this other one was famous. It is exactly the same reason this one's famous, and that is you can just look at it and you already know a point on there. Watch this. Watch how easy this is. If you make x, here was convenient to make x equal 0. When you made x equal 0, you could tell that y was b. Here, the reason it's so famous because if we choose a clever value for x, we will know the point on there. We'll make x equal 1. Think about why that's clever, because that's a good idea, because then 1 minus 1, this is 0. So the right side is 0. So what does that tell you about about y? Y has to be equal to 2. You see how easy that was? In other words, just by looking at this, you know a point on there. It has to be whatever this h is. You just make the x the opposite. This will kill it, and that will give you 0, and that will make y the opposite of k. So there's a point, and this, of course the slope is still 3. So in one step you can graph this one. All right, let's do it. Let's do it. Talk is cheap. So if you have something like this, y minus 2 is equal to 3 times x minus 1. Again, immediately you know a point on there. It's 1 and 2. When x is 1, y has to be 2, so that both sides are 0. Or said differently, if you plug in x equals 1 here, whoa, x equals 1 there, that gives you 0 on the right side. That makes y 2. There's a point on there. So you know it's got to go through here. X equals 1, y is equal to 2. You know it's got to go through there. And once you know it's got to go through there, then the only thing that's left to figure out is the steepness. How steep should it be? So you know it's got to go through there, and you just wish you could figure out the steepness. Is it this steep, or that steep, or that steep? How steep is it? Well, for that we look to the steepness place, where the steepness lies, and that would be right here on the slope. The slope is equal to 3. So every time you rise 3, you rise 3, you run 1. So let's make this the right steepness. So how steep should it be? Rise 1, run. So you run 1. Here it is. You run 1 and you rise 3. So it has to go through these 2 points. That's the steepness right there, determined by the slope, of course. In this way, every single time you see an equation in this form, it should take you about 2 seconds to graph the line. Here, try that again. Suppose you had to graph, I don't know. Let's do y plus. Let's do some pluses. Y plus 4 is equal to 1/2 times x plus I don't know, 3. So a clever point to graph on this would be whatever makes this 0. -3 would make it 0. And if the right side is 0, what does that make the y? Think about it. Use your calculator if you need to. If y plus 4 equals 0, what does that make y? Well, it would have to make y -4. So you already know it has to go through the point -3, -3, -4. Right here. It's got to go through that point. At that point, all you got to do now is determine the steepness. It has to go through that point. For sure. You're just trying to figure out how steep should it go through that point. Well, for the steepness, we look to the steepness place right here. That's where the steepness is. The slope. The slope is 1/2, which means every time you run 2, you rise 1. So from here, I'm going to run 2 spots, and I'm going to rise 1 spot. That marks the spot. That's it. That's all it takes. Then you just join the 2 lines, and you're set. See how easy that was? All you need is a point and a slope. Game over. A point, you figure out the point, and then the slope, you figure out how steep. Okay? Try that again. Let's mix it up a little bit. Yeah? Suppose we mix it up. Say we want y minus 3 is equal to -2/4. I know it's not reduced. Who cares? X plus 1. This is exactly the famous point-slope form, and the reason it's famous is because you can look at it and you can see a point on the line and you can see the slope of the line. Here, if you have trouble, you can make a little chart here. What would make this a 0? X equals -1 would make it 0, and if the right is 0, what does that make y? If you have y minus 3 equals 0, well, y must be positive 3. So that tells you a point on the line, -1, positive 3. Boom, right there, -1 up 3. That's already half the problem is already done. Now we just need to figure out the steepness. For the steepness, all you do is look at the steepness part of the equation. This part right here tells you the steepness. -2/4, that's the rise over the run. So I run 4 units. 1, 2, 3, 4. There you go. I ran 4 units. Then I rise -2, so I have to go down 2, down 2. Make a little mark there and connect the dots. So easy to connect the dots. You just go like this. There it is. Just like that. Point-slope form. Nice, huh? It's almost the same as the y-intercept form. The only difference is that the starting point maybe is not the y-intercept, but the point that it's given by these numbers right here. Okay, that's the initial point, then the slope. Okay. Last time? Let's do it last time. One for the road. I can't make this difficult. I don't know what to do. It's so simple. Let me try something. Y plus 1 is equal to, let me see, -3/2 times x plus 3. There you go. So you just think about it and you try to think, you should be staring at one of the points. One of the points would be -3, -1. It's because -3 makes the right 0. The left would be 0 if you make it by -1. So you go 1, 2, 3, -1. There's a spot. Then you think to yourself, oh man, I know it goes through there, but I only wish I knew how steep it is. Well, we do know how steep it is. You got the slope right here. That tells you the steepness, the rise over the run. So I'm going to go ahead and run 2 units. How many units is that? 2. Then you got to rise -3. That means you're going down, baby. Down. 1, 2, 3. Then you make a little mark there, and that's it. You just connect the dots. As easy as it sounds, that's all it takes. This stuff is piece of cake. There you go. That's the graph of the line. Let me think.